Good afternoon, or morning. Wow, I about said afternoon. Good morning, everyone.
Morning.
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 All right. Oh, I gotta get you all the link. Chat. iPad in here. I see that it's 8 o'clock, so here's the link one more time. Go away. We're going to start today's daily quiz. So it deals with that factoring, the synthetic division, polynomial long division. But all I'm asking for is the remainder. So I'll have a nice little setup today to share it to screen. I'll write it on Blackboard. So if you go to the poll link everywhere, you'll see it up. I want you to find the remainder, black. From taking the polynomial 2x cubed minus 5x squared plus x plus 2 and dividing it by x minus 2. Okay. So find that remainder. That is your goal for today's daily quiz. And I saw a couple people come in right at the last minute. There's the link again. So I'm going to give you all just until a few minutes and see how quickly y'all get responses in. So what is the remainder? You can use either polynomial long division or you can use synthetic division. It looks like we actually might have everyone here today. Awesome. All right. Yep. And again, I'm just looking for the remainder. You're welcome just to type in the number as well. Don't do anything fancy. Just type in the number. I'll give you all till 8:05, which is 1 minute or 1 minute and 50 seconds. Yeah. From now. Again, I'm asking for the remainder. So a couple answers. I'm looking for the remainder. All right, 50 seconds left. Looks like we got most people in. Maybe a few stragglers. Looking for the remainder. You have 30 seconds to get your answers in. All right, you've got 5 seconds to finish typing in your answer. I'm locking it in 3, 2, 1. Locking answers now. All right, good job for most of y'all. I tried giving all the cues for a couple people. Some of you put in what I believe to be the quotients. If I remember this problem correctly. I was asking for the remainder. So, like I said, you could do polynomial long division. Easier way would be synthetic division. So if I have, whoops, if I shut off. So we had the problem, polynomial was 2x cubed. Whoa, it's back now. All right, 2x cubed minus 5x squared plus x plus 2. I use those as my coefficients. 2, -5, 1, and 2. And then what I use when I use synthetic division is the root that comes from the factor x minus 2, which would be a positive 2. And the process for synthetic division is drop down that first number, which will be a 2. And then I move up and to the right to go to my next coefficient. Every time I go up and to the right, that's when I multiply by this root that I'm testing, which is 2. So 2 times 2 is 4. And then I'm always just adding the numbers together. So -5 plus 4 is, let me erase that plus sign over there. Make it look like a plus sign. -5 plus 4 is -1. I move up and to the right again. -1 times 2 is -2. Now 1 plus -2 is -1. Move up and to the right again. And -1 times 2 is -2. Whoops, use that in black. And then my remainder, which will be that always that last number, is when I take, in this case, 2, add it to -2, I get 0. So the remainder is 0. Another reason why we loved synthetic division is because it not only gives us what the remainder is, it also gives me the coefficients for the quotient polynomial, which in this case would be 2x squared minus x minus 1. And then just a little bit that you kind of see some in the homework, but we weren't able to fully talk about on Wednesday, is that if this is a remainder of 0, this actually means that it is a factor. So because it's the root. So if you're looking for synthetic division, it's always between, okay, if x minus 2, I'm answering a question from someone who sent it privately, sent a private message to me in chat. You set that, what you're dividing to, equal to 0, your factor, which means the root that you're looking for is 2, because synthetic division is really a root finding method. And getting that remainder being 0 tells us that I not only found a root, but I found a factor. So overall, Oops, you get an O there. We have that this 2x cubed minus 5x squared plus x plus 2, I can factor out an x minus 2, and then I'm left with that 2x squared minus x minus 1. Okay? So if I can find a root, find a factor, which those are synonymous, there's two different lenses that we got to look through, then I can see at least 4 cubics. Once I find one, what I'm left over with is a linear factor and a quadratic. And quadratics are something that we study a lot, we work with, right? We've spent already a few days just studying quadratics, graphing them, finding roots, etc. So once I get down to seeing a quadratic, that is then something that I can factor. So this is the process that we're going to be taking with trying to factor cubic polynomials. Say, hey, can I find a root for that cubic polynomial? Go ahead and pull its corresponding factor out. And then what I'd be left with, once I pull out a factor from a cubic polynomial, is a quadratic. And I'd be kind of back in my more familiar zone, and I'll be able to factor there. Okay? So that's where that video that you were supposed to watch, at least one of those two, I gave you two different explanations for, or two videos you could watch on Blackboard for rational roots for today. But that's what it does. It allows us to create a nice little list of potential rational roots. The key word there is potential, right? It might include it, it might not have it, it just depends. But we know that if there's going to be a rational root, it comes from this list. And then I use something like synthetic division to quickly test to see if when I use that root, do I get a remainder of 0? i.e., is it an actual root for that polynomial? Okay, so we're going to be practicing doing this process. So we're going to find the list of rational roots, and we're going to use that to try to find roots, factor it down, and completely factor a cubic polynomial. So I'm going to pop up a question here and poll everywhere in a second, but I wanted to pause and see if anyone had any questions. And if not, please give me a thumbs up. Cool. I got 6 people respond, but I'm not hearing any questions. All right, there we go. Now they're coming in. All right. So, next question is now available. So I want you to list all possible rational roots. So these aren't the actual rational roots, they're just potential rational roots from this theorem that you watched that video on. So list all possible rational roots for that polynomial 2x cubed plus x squared minus x minus 1. And as you saw in the videos, and when you read about this rational roots theorem, you always have to kind of consider the positive and negative cases, which means you get a list of positive and negative roots. When you type in your answer, just to try to simplify it so you're not having to worry about what you're typing in, don't worry about a plus or minus symbol, just list the numbers. And then we'll have this assumption that when you're typing your answer, you're considering both the positive and negative values of those numbers. Hope that makes sense, but just give me the numbers, right? Don't worry about the plus or minus. We're going to assume that it's there for y'all when you type it in. My phone. So let me write it on Zoom. I can't share my screen too well here. got it up there on Zoom now. That is our question. List all potential roots of the polynomial 2x cubed plus x squared minus x minus 1. All right, I already got some answers in. Good answers too. So y'all watch the videos again. Yay! Good job, everyone. All right, we're getting a lot of answers in. Give us just one more minute. Got over half of responses from y'all and good responses as well. All right. I'm going to lock answers here in 10 seconds. I'll give you 15. We're missing just a few. Give you a chance to type it in. All right. Locking answers in 5, 3, 2, 1. Locking answers now. So, good job overall. Answer your list of potential rational roots should have been plus or minus 1 and plus or minus a half. Okay, most of y'all got that, but let's get a review real quick for where they come from for those of you who did not get that as your correct answer. Okay, well, the key, and when you reread that rational root theorem, is always you're trying to look for values p over q. And when I get this p, it's always going to be the value. Let me rewrite that c. Factors of your constant term. Factors of your constant term for your polynomial. That constant term is the number at the very, very end that doesn't have an x term associated with it. Right? So in this case, it would be -1. The q, the stuff that is thrown into the denominator for all these rational factors rational roots are factors of your leading coefficient, LC, leading coefficient. So I look at my polynomial and I say, okay, where's my highest degree term? Oh, it's an x cubed. What's the number attached to that x cubed? It is a 2. So when I take this theorem and I list it up, it's, okay, well, I need factors of 1 or -1. And factors, whoops, let me rewrite that. Factors of -1, and then factors of 2. And these are relatively simple. And one of, again, things we had to remember from the theorem is we had to consider both positive and negative. In this case, we're going to consider both positive and negative factors. Well, for -1, it's pretty simple in that it's just either a positive 1 or a -1. For factors of 2, I've only got 2 of them. Things I can divide it are plus or minus -1 and plus or minus -2. So I need to take all factors of -1 and divide them by all factors of -2. So in the videos, you see them write it like this. This is one way that a couple people write it. to kind of give us the setup, right? Make it easy to see, okay, I got to take everything that I see in the top, divide it by everything that I see in the bottom. So I have to take, just to write out the nice little expansive list. Well, it's good to see for the first time that we usually shortcut it. So I can take a positive 1, divide it by a positive 1. That is one potential rational root. I could take a negative 1 divided by a positive 1. That's another potential rational root. A positive 1 divided by a negative 1. Or a negative, negative 1 divided by a negative 1. That's potential. Like, you just see me, I'm listing out every possible combination, positive, negative. Of those, I could do positive 1 divided by positive 2. Negative 1 divided by positive 2. I'm going to just wrap the list down below. But I'm continuing on. A positive 1 divided by a negative 2 and a negative 1 divided by a negative 2. So that's all the different combinations. And if you simplify them down, you just see that that list comes out to either a positive 1, a negative 1, a positive 1/2, or a negative 1/2. You'll see these just getting repeated once I simplify these signs down. You're just going to see either positive 1, negative 1, positive 1/2, negative 1/2 appearing in just multiple spots in that list. So then I compile them together and I get my nice little list of rational roots. And this is a nice set, so I'm going to put that nice set notation around it, those curly brackets. It's a really nice way to do it. And a nice way to convey to a reader that this is kind of my final answer. This is what I'm trying to get you to look at the very end. In that the list of rational roots for this polynomial are plus or minus 1, so either a positive 1 or a negative 1. And then also a positive 1/2 or a negative 1/2. So just quick questions about how we find it. Anyone got any questions? If not, please give me a thumbs up. Slowly coming. Cool. Main thing is, though, I'm not hearing any questions. All right. So factors in -1 are just what can divide -1. The only things that can divide 1 really is just 1. Only integers that can divide 1 evenly is 1. So when we're looking at whether a positive 1 or -1, the factors of it are always going to be either a positive 1 or a negative. Because only 1 can divide 1. You got a question in chat. That's what I'm trying to answer. If you're kind of confused on what I'm talking about. All right. Give a second for other questions. So for cubic polynomials, these x to the cube polynomials, this is the first step that we're going to be doing to end up trying to factor or find all the roots for these things. Because this list right here, the very, very powerful thing is that if there is a rational root, a rational number that is a root of this polynomial, it is in that list. Not all of these numbers will be roots, but if there is a root, it is in that list. So once we have that list, we don't have any fancy way other than synthetic division to check to see if they are roots. So that's going to be your next step. I'm going to pop it up on poll everywhere. But you're going to need to use this list of rational roots. And we're going to factor the polynomial completely. But as I was saying with that daily quiz problem, right, once you find one root for a cubic, I can pull out that factor and then I'll be left with a quadratic. And then once I'm left with trying to factor a quadratic, that's back in my little home territory where I'm really familiar with, stuff that I'm really familiar with. So go ahead, we've got our list, and we're going to factor that polynomial. 2x cubed plus x squared minus 2x minus 1. write it out as well. So using potential rational roots. Plus x squared minus 2x minus 1. All right, get the problem up in Zoom as well. So again, just use synthetic division. You just have to pick and choose which roots you want to test. They come out to have a remainder of 0. That through synthetic division, that means you have a root. And then you not only know what your factor is, because it's the linear factor that corresponds with that root, but then you're also know what you're left over with after you pull out that factor. And just for the first person who responded, it is factorable. So you got a few minutes left if you want to actually change your answer. This is factorable. Looks like one person already got it. Since this does take a little bit, I'm going to give you all just until 8:30. Okay. Give you all until 8:30 at the latest. Let me see how quickly people get answers in. Go ahead and feel free to ask any questions right now if you got them. All right, you got just under 2 minutes left. Seeing some good answers come in. So I'm not looking for the quotient here, just because I got that coming up a couple times. I'm trying to factor this entire polynomial. You're left with an x squared term as a multiplication. That means you can factor it. You can factor quadratics. Make sure you're factoring your quadratics as well. It's a two-step process at this point. But there are good answers coming in. All right, and like always, at least give me your best guess. So I'm going to give you all 30 more seconds just because I'm seeing some answers come in. Give you a chance to type it up. Alrighty, so 15 seconds. All right, I'm going to lock answers here in 5, 3, 2, 1. Locking answers now. Okay, first thing is first. I want to get a thumbs up if you are still here and with me, because I know I made some of y'all wait for me. Please give me a thumbs up if you are still here and with me. It should be everyone. Cool. All right. So, like I try to help you off on the right path, because I don't think in the video he actually covers anything like this. But you got this list of potential rational roots, and we use them. So I just have to go look at this. I have 4 choices here, right? I have -1, +1, -1/2, and +1/2. I just get to choose which ones I want to test. So I'm going to ask y'all, which number should I test first? Should I try -1, +1, -1/2, or +1/2?
+1.
+1. So I want to test to see if +1 is a root. So I set up my synthetic division. I write out my coefficients of my polynomial. So 2, 1, -2, -1. And through synthetic division, if 1 is a root, that means I want to have a remainder of 0. So we always drop down that first number. So drop down that 2. And then I go up and to the right, go over to the next coefficient. Every time I go up and to the right, I multiply by my root. In this case, it's just multiplication by 1, so not a lot of crazy stuff is happening. Oops, I want to be in blue. So 2 times 1 is 2, and then I add the columns together. 1 plus 2 is 3. I take 3, multiply it by 1, that gives me a 3. Take -2, add it to 3, add it to 3, I get a +1. 1 times a 1 is a 1, and then a -1 plus a 1 is a 0. So this tells us that 1 is a root, which means x minus 1 is a factor of that polynomial, 2x cubed plus x squared minus 2x minus 1. Because if I plugged in a +1, this would end up becoming a 0, making that entire polynomial 0. And this not only tells me that I can factor out an x minus 1, but also what I'm left over with. So that 2x cubed plus x squared plus 2 or minus 2x minus 1. I can factor out an x minus 1, and I'll be left with all those coefficients right there tell me a 2x squared plus 3x plus 1. And this is where, again, I was trying to cue you up where, okay, I have a linear term here. That's as far factored down as I care. But now I have a quadratic. And that quadratic is something I should feel comfortable with being able to factor. I might not see what it is right off the bat, and that is absolutely fine. But I should be able to have the confidence to say this is quadratic. I should be able to try and factor it. There's many different ways you can do it. You can look at it, see if you can figure out the right coefficients so that you can factor it into something. You can use quadratic formula to find out what the roots are and then use those roots to determine your factors. But either way, you would see that if I tried to factor this out, you'd get x being, I would have to multiply two x's together. One would have to be a 2x, the other one would have to be an x to get that 2x squared. And then I have to figure out, okay, well, what are my factors of 1? Well, they either have to be both positive 1 and both negative 1, but I have a positive 3 right there in the center. So my only option would for both of those to be positive 1. So that 2x squared plus 3x plus 1 will factor into 2x plus 1 times x plus 1. Okay, so questions just so far, this is what I wanted you to ask, but I also want to make one quick observation, but I want questions from y'all first. If you got them, thumbs up if you're good. All right. So this is not the only choice we could have made for a root to test through synthetic division, right? We could have chosen a positive 1/2, negative 1/2, or a negative 1. I just want you to note, so we had our list of rational roots, positive 1 or negative 1, positive 1/2, or negative 1/2. This was the potential roots. And the great thing about that theorem says that if it is a rational root, that root has to appear in that list. And if we go back, right, this was our polynomial. Nope, just plus an x minus, okay, so 2x cubed plus x squared minus 2x. And we said this factors into x minus 1, 2x minus or plus 1, and x plus 1. So if I set this polynomial equal to 0, we know I'd get a couple different roots, specifically 3. We get the one that we found through synthetic division, right? X being 1. And that is in that list right there. Not only did I get x being 1 to be a root, if I look right here at this other factor, x plus 1, well, if I set that equal to 0, that tells me another root is negative 1. And guess what else was in that list? It's kind of hidden there in that plus or minus, but it is also a negative 1. Hey, so negative 1 was also in that list. If I'd have got lucky and chose negative 1 off the start, I'd have found another root. If I would have tried 2x plus 1, right? We'll set this equal to 0. This is 2x is equal to negative 1, or x is equal to negative 1/2. That was also a root, a potential root in that list, right? It did show up. All three of these actual roots for that polynomial did show up in that list. There's only one number in that list that wasn't actually a root, but that's fine because the key word I'm always going to keep saying, and I want you to pick up on, is potential roots. Okay? If it's got a root that is a rational number, it will appear in that list. But we're not sure which ones are actually roots when we create the list. I wanted y'all to see that and also know that if you chose a different number other than 1, chose negative 1 at the start, or potentially even negative 1/2 at the start, you would have found that you also would have had a roots. One of the harder things about this process is at the start, unless you get lucky, sometimes you're just going to have to keep trying different potential roots until you get lucky. All right, you might pick a good one on the first try, or you might have to test 4 or 5 different roots before you actually get to one. It's part of the pain of the process, but this is really the best way to factor quadratics. Or not quadratics, cubics. Cubics. Okay. So if you got any quick questions just after that, you are more than welcome to ask. If not, you're welcome to go to poll everywhere. I've got a new problem up. We're just going to do this process again for the last 10 minutes, okay? First question, I want you to list all potential rational roots. And then once we have that list, we're going to go through and try and factor the polynomial that's given. Okay, so for this problem, we are given the polynomial this time is x cubed. Oops, let me erase that and write it in black. X cubed plus 3x squared minus x minus 6. And the first thing we're trying to do is list the potential rational roots. And list the potential rational roots. And same thing as last time, we know we have this plus or minus, right? I'm not going to ask you to type or worry about typing in plus or minus. I don't want you to have to worry about that. Just give me the numbers, and we're assuming that when you type it in, you are considering the positive and negative case. Already got one person in, awesome. You are absolutely correct. 2 people in now, yeah. I'm just going to give you all 1-2 minutes so we can make sure we can get to the factoring part, because that's where more of the work is. I'm seeing good answers come through. So good job. All right. And just for the sake of time, I'm going to give you all just 30 more seconds. I know it's not a ton of time. Just 30 more seconds. So list all possible rational roots, potential rational roots for this polynomial. Yep, thank you for putting in chat, Shamar. And you're good. All right, so I'm going to lock in 3, 2, 1. Locking answers now. But most everyone did get the correct answer. So just really quickly, so we can go on to the factoring part. Well, I'm getting this list of potential rational roots. I always have this P over Q, right? So in that P, that number P always comes from taking factors of my constant term, right? The number at the very end that doesn't have an X associated with it. So in this case, it would be factors of -6, and I consider both positives and negatives factors of -6. What goes in the denominator is factors of my leading coefficient. Well, again, I have an x cubed term here, so it's just an x cubed. That means its coefficient is 1. So when I'm creating my list, I need to take all factors of -6 divided by all factors of 1. Well, in that denominator, factors of 1, relatively simple. The only things that can divide it are +1 and -1. Okay. Factors of -6, there's some more to it. But 1, 2, 3, and 6. And then considering both the positives and negatives of all of them, that will give me all the numbers that can go in the numerator. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And if I go through all of these combinations of dividing it and simplifying some signs down, I see that my list becomes, well, either plus or minus 1, positive or negative 2, positive or negative 3, and a positive or negative 6. If you're wondering, well, it looks like I just rewrote what's in that numerator down here in this list. Well, that's fine because I'm taking all those numbers and dividing it by either a positive one or a negative one, which means I don't do anything to it or I change the sign. But as we see, we're always accounting for both the positive and negative case. So you take positive negative 1 divided by positive negative 1, you get a positive or negative 1, etc. Okay. So this is my list of potential rational roots. This is what I got to look in because our next goal is to factor. Okay. So I want you to now factor this polynomial that we have this list of rational roots. So go through that list, and I need you to just synthetic division, test a few roots until you find one. Right? You might get lucky and find a good number right off the start. If you don't, that's fine. You just got to test a different one. Okay? So I know we're kind of running out of time, so I'm going to give you, let's say, until 8:48. 8:48. That's not a lot of time. We got just under 2 minutes until I want y'all to come back to Zoom real quick. Oh, already got some answers in. Awesome. All right, so 30-ish seconds. We'll lock answers, bring you back to Zoom. There we go. All right, I know this wasn't enough time, but we're just kind of at the end of class. So I'm going to lock answers here in 5, 4, 3, 2, 1. Locking answers now. So more what I care about, obviously, is that you're kind of getting on the right path, getting down the right path. If you didn't have time to type in your answers, that is fine. I know the time. We're just going to go through the process and kind of check yourself, see if you're doing the right or same type of reasoning. So like we said, in the last problem, this problem, we just have more roots to choose from, but I need to just choose some roots and see if one of them would work. So I could test something like, I don't know, 1. Let's see if 1 is a root real quick. And I use synthetic division to do that. So I have 1, 3, -1, -6 for my coefficients of my polynomial. Drop down the first one, go up and to the right. I'm going to quickly do this synthetic division. Every time I go up and to the right, I multiply by my root. So I see that the remainder in this case would be -9, which means that 1 is not a root. I could also try -1, right? I could try different things. I'm going to shortcut and save us some time, go to -2. Get this out, so it'd be 1, 3, -1, -6. Drop down the first one. 1 times -2 is -2. 3 plus -2 is 1. I get a -2 there, giving me a -3 when I add them together. -2 times -3 is a +6. Oh, hey, looky there. Now I have a root. X minus 2 is a root. Or sorry, -2 is a root. Whoops, it wasn't going to let me fit that in there. So x plus 2 is a factor. And this tells me that this x cubed plus 3x squared minus x minus 6, I can factor out an x plus 2. And I would then be left with an x squared plus x minus 3. Okay? From there, I would need to look at this and say, first it would be -9 because you add them together, Mona Lisa. You're adding the numbers together. So I'd look at x squared plus x minus 3, and I would try to factor this. It doesn't have a nice, easy factor. If I wanted to get down to the roots of this, I would probably need to use quadratic formula. Okay. But you would see then that your roots from this quadratic part are not rational. They'll be irrational numbers because you're going to have numbers under a square root, which is why they wouldn't show up in that list. Okay. So, questions? Just writing that out. Not rational roots. Questions, questions, questions. If not, give me a thumbs up. All right. Coolio, coolio. So I'm going to stop the recording. Y'all are good to go. If you have any questions about anything else, you're more than welcome to stick around and ask. But I'm stopping the recording now.